But you have to know how it contains the information. Unfortunately, we have a tradition on this well. It's an important Kabbalistic book called the Pardes Rimonim from an eminent Kabbalist in Sfat about 500 years ago called Rabbi Moshe Cordovero. And he explains the methodology. Now, once again, it's important to realize this is before modern science, really before modern math. And yet he says there is a tradition of how the Torah contains, I erased it, roughly this amount of information. And with this, yes, it is mathematically possible because it's a much, much more complex way of encoding than merely the way we read the alphabet, or even a more primitive one would be like, say, the binary code, which is used for what? Computers. That's the most primitive information system there is in codification. Why? Because there's only two letters. It's like A and B. So what do you do for C? It has to be like AAB or whatever. Okay, it's the most. You need the most information in order to be able to encode things. Okay, but with this, as he says over here, it's using things like switching letters, first and last letters, shapes of letters, first and last versus skipping of letters, and letter combinations. Okay, now it is technically speaking possible. The researchers have to sit down with the peer review board and work out whatever they're going to look up, how they're choosing what they're looking up. Because once it's all agreed, we know exactly how the researchers choose what they look up. There's no way you can hide the bad results. Now the peer review board doesn't even need to see the results of the researchers. They can completely run the experiment themselves based on the algorithm and see how they compare. Okay, so the algorithm that was agreed to was rabbis again. Remember, we had the original success with the Rabbi Weissman in the 1950s, 1960s, was with rabbis from the medieval period, the Rambam being one of them, who's listed somewhere over here. Where is he? Anybody can find him quickly? Come on, Rambam. There he, no, that's Rabbi Avin. There's a son of the Rambam. He was also a big rabbi. Where is he? 29. There he is, the Rambam. Rabbi Moshe ben Maimon. Okay? So he said, that's what we're going to do. We're only going to look up medieval rabbis. Okay, now there was a lot of medieval rabbis. So how are you going to choose them? The answer is, first of all, just take one source. The most agreed upon standard encyclopedia on medieval rabbis. Fine. Still too many medieval rabbis in an encyclopedia to check. So the rule was, very sensible rule, because you can't look up all. Computers are not powerful enough. So what do? Every rabbi that had at least 3 paragraphs written about him would have to be looked up. Any rabbi less than 3 paragraphs, leave him out, okay? And also you have to decide what you're looking up. Every time look up a different thing. You know, one time this is his first name, his last name, his birth date, his favorite flavor, ice cream. No, it has to be consistent, because that way you know not playing around. What's the most common standard thing on the rabbis? The one thing that was easy to check that was consistent with all the rabbis? Date of death. By the way, date of death is much more common than birthday. Why is it? Why is birthday harder? Yeah?
When they're born, if they're a famous rabbi, nobody really cares when they were born, because nobody really knows about them when they're dead.
Yeah. In other words, when they're born, they're not a famous rabbi yet. Okay, and back then they didn't have public records. You didn't get a birth certificate. Okay, but when they die, oh my gosh, it's a big rabbi, and dun 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 dun. You got a tombstone. It's got the date on. Okay, so it's very easy. How many rabbis made that description? In other words, they had at least 3 paragraphs written about them, and you have the date of death. Okay, 34 rabbis. So great, you have 34 rabbis that meet the criteria. There's also one other small trick, though. What's that one small issue? Okay, the rabbis are known by a lot of different names. Which one do you look up? Like, for instance, the Rambam. That's not his real name. His real name was Rabbi Moshe ben Maimon. But in the Jewish world, he's known as the Rambam. On the end of the world at large, he's known as Maimonides. Like, what do you choose? So the problem is that a lot of time, like a lot of famous rabbis, nobody, even scholars, have any idea what their real name is, because nobody ever refers it to him that way. So what they did is they went to the guy who's considered the world's expert on rabbis' names, not surprisingly if you know of Israeli universities, a professor at Bar Ilan University. He is considered the world's expert, so actually he died recently, on rabbis' names. And he said, he gave the list of what appellation to look them up as. Okay? So fine, everything is now set in place, and they run the experiment. Here's one example. This is the Maharshal, a famous rabbi who lived about 500 years ago. There you have his name. There you have his date of death. Okay? And now, by the way, it just happens to be there was around there you have his first name. You have year of death. But first name and year of death, even though it's kind of cool that they appeared, are completely and utterly irrelevant. Why are they completely and utterly irrelevant? It's not part of the algorithm. Bingo. Okay, so those are not included. So therefore, when you do statistical analysis, the mathematical likelihood of such a thing happening, you are only comparing name and date. Okay, now if you're wondering how the statistical analysis is done at this point, it was basically through distance. You have what is the distance between the two words. In this case, it would be 7.21 letters over a text of the size of 309,000 letters. That gives you an idea of how the likelihood of something happening on that kind of text. Okay? By the way, we're going to do better. There's better statistical analysis later because of the experiment that's going to happen, but I'll show you that. Okay? So, by the way, I'm going to tell you now, speaking of cherry picking, I'm cherry picking. How many rabbis were done in the experiment? 34. And guess what? I am showing you easily one of the best results. Because not all of the rabbis actually appear. In fact, there was 34 rabbis. Over here we had 1 out of 20. Out of the 34 rabbis, how many actually appeared? Not just this one. 32 out of 34. The other two, name and date, totally far apart, statistically irrelevant, totally likely to happen by chance. What do you think? We have a statistician here. Okay. From a mathematical perspective, getting 32 out of 34 rabbis is quite good. It is statistically significant. Very good. But you're not looking from a mathematical, you're not looking from a scientific perspective. You're looking from a philosophical perspective. And you're right, Shimon. There's something wrong. Like, hold on one second. Like, if God gave the Torah through prophecy and it's supposed to be containing all the information in the universe, all 34 rabbis should appear. What's going on? Why only 32 out of the 34? Okay, but right now we got to not be so religious. We got to be not so philosophical. Remember, we have our math thinking caps on, not our kippas on, okay? And we're looking only from the perspective of math. And this is statistically significant. In fact, it's so statistically significant when the researchers, Professor Rips et al., gave the experiment to the statistical journal. They were freaked. They were angry. They were upset. They're going, oh my God, we're not going to publish this. What do you mean we're not going to publish this? Are you crazy? We're going to put in our esteemed journal evidence that God wrote the Torah? I don't think so. Come on, this is not the National Enquirer. But we did everything you said. I mean, they had a whole back and forth. It was kind of ugly.
If you happen to do it for Rabbi Moshe ben Maimon, the way he was born.
We'll get there. Hold the thought. Hold the thought. Okay? Because we're going to get to your question. But the point is that as it was, though, the algorithm was accepted by the journal. It was successful, 32 out of 34. Now the journal is freaked out and said, why'd you make us do this whole thing? And they're like, well, we didn't actually think it was going to work. They just thought they were going to get rid of him. Now they're stuck in this crazy situation where they won't even dream of publishing this kind of thing, but on the other hand, they're kind of stuck to have to do it. So in the end, they come to a compromise. The compromise is, this is what we want you to do. We want you to go to the guy who's probably arguably one of the greatest statisticians alive today. His name is Percy Diaconis at Stanford University, chairman of statistics at Stanford University. You didn't happen to go to Stanford, did you, Kaylee? Wasn't? Okay, fine. It wasn't your professor. Okay, but anyway, you can look him up. He's one of the biggest in the fields. But even more than that, why did they really choose him? You see, huh?
They thought he would find the flaw.
Why him particularly? No, Percy Diaconis. Come on, he's Greek. Huh? Why did they choose Percy Diaconus? Why did they choose him? Huh? Yeah, well, maybe he's the best, but for sure they thought he was the best for this. You see, Percy Diaconus, not just being a full tenure professor, not just being the chairman of statistics at Stanford University, he also happens to be a board member of the American Skeptics Association. And what do? Debunk any kind of what they feel is like a pseudoscience kind of phenomenon. In fact, he is most famously known for using statistical analysis to totally tear apart scientific experiments that were done in the 1970s, seemingly proving that ESP exists. Everybody knows what ESP is? Right, mind reading, okay. There was experiments done in the 1970s seemingly proving that there was such a phenomenon. He did the statistical analysis and he ripped it apart, okay. They're like, he's the guy to disprove this, okay. So he throws all sorts of different experiments. In fact, some of the ones that Jonathan mentioned, maybe because of Hebrew, there's more combinations because of not having valves. So basically using controls like looking up the rabbis with the names and the dates in the books like, say, the Moby Dick, War and Peace, and,
Yes, we have to have a control.
Right, okay, so he gave them control after control after control after control. We don't have time to get in all the different ones, okay? Yes. None of them, on all of them, the Torah codes passed and the control failed. Okay, so finally at the end he gave, and Kayla can verify, this is like the most strict form of control, which is called actually a negative control. You're actually not looking up what you're supposed to be looking up. Rather, you're looking up the wrong information. Basically, what they had to do is this. Instead of comparing to Moby Dick and Hebrew and things like that, it's let's look up for the rabbis and their names of dates, their date of death, in the Torah itself, but what's called a monkey text. A monkey text, basically, you take the actual text itself and you randomly scramble it. Okay, it's the closest you can actually get to the real text, but it's not real. Okay, and then you're going to look up the rabbi and date of death, but not his date of death. The wrong date of death. If you're looking up the Rambam, you look up, say, Rashi's date of death. Notice it's a negative control because you're not looking up the real information. You're looking up the wrong information. So why would you do that? How would that help? Because if on a fake Torah, a monkey text Torah, you get Rambam with Rashi's date of death coming close together, in other words, something that looks like this, and of course, that's not for real. That's fake. So that's telling you this is also by chance. And it just happens to be the nature of the text of the Torah lends to have certain mathematical patterns like this, but it's not done by design. It's purely by chance. Okay? This is all what's called in the statistical field of pattern recognition. Okay? So that's what he did. He says, okay, great. How many times do we have to run this experiment? He says, not too many times. So it's not too many times. 1 million times. 1 million times? That'll take us years. Yeah. That's my point. Bye. Okay? Roughly 4.5 years later, they come back to Percy Diaconus, knock up Stanford. Hey, Percy, we're back. Ha-ha. Okay, he wasn't happy to see him because he knew he was in trouble if they're still there. Okay? And the results were, guess what? The Torah did great. Because now they can compare to the real Torah to 1 million fake Torahs, which means you can use a much better statistical analysis, which is called the Monte Carlo method. Monte Carlo method, named after, like Vegas, well, not Vegas, Monte Carlo, okay? Which is basically, you just rank of the fake Torahs with the real Torah, which ones the names and the date of death, how close they came together, and if the Torah compared to the fake test, was it average, high, low, you can see where it falls. Then you'll have a real solid statistical number of how likely this phenomenon is. Okay? So now Percy Diaconus goes ahead and signs this, I hate to say it, he signed practically with his own blood. We have the letter, I cannot find any problems with the project. You can go ahead and publish it, etc., etc. But here's the key. Every scientific journal, before they print, they have to have a certain amount of probability that they accept as reasonable or not. Okay, and the truth is every journal can choose what that probability is. Now, most experiments are usually 1 out of 20. What does that mean? It means everything has a possibility. Any experiment ever run, it doesn't have to be for what they think the reason is. The phenomena they're saying is the cause. It could just be random chance. Okay, if whenever you run an experiment, if the odds of the phenomena not being from the cause you're saying, but by random chance, is even 1 out of 20. In other words, 5%. Oh, another dead marker. 5% chance versus 95% certainty. Okay, that's already too much chance. You have to have less than 5% by chance. Okay, but depending on the subject matter, journals can be more strict. Like, for instance, especially with like medicine, usually the standard is 1 out of 50. In other words, we have to be 98% certain that the new medicine really is the cure. Okay? And if there's even a 2% chance of it not being the cure, just random coincidence, not good enough. Okay? But over here, they gave a very strict standard. 1 out of 1,000. What does 1 out of 1,000 mean? It means we will not publish. We don't care about your work. We will not publish unless we are 99.9% certain of the results. Because, once again, we're talking about evidence that God wrote the Torah. So in the end, when they did it, what were the odds of it happening by chance? Remember, it has to be
Less than
1 out of 62,500. What's that? Beat 99%? Yeah, that's somewhere in the range of like 99.98%, something like that. That's how good it was. So did they publish it? Yes, now they had no choice. There it is, August 1994. Now, of course, they tried to keep it as hush-hush as possible, very, very like light sounding, equidistant letter sequences in the book of Genesis. But guess what? News got out, world headlines. I remember I'm from LA, so I saw front page of the LA Times, front page of the Wall Street Journal, New York Times, everything, okay? Discovery Channel, History Channel making specials, and that's when you got all these people, the fakers, so to speak, looking in the Torah and selling, bestsellers of, I find when Yitzchak Rabin is going to get assassinated. Not that mention Christians trying to find codes in the New Testament, Muslims. What? It's statistically totally irrelevant. Yeah. Totally irrelevant, okay? And also with Muslims finding on the Quran and everything else, okay? But all those other things, not done by statisticians, no real statistical analysis, okay? But it became the pop thing, okay? Now, how did the atheist community take this? Not so happy, not so excited, okay? They have to find a hole in this, okay? Now, also the journal was getting a lot of slack. So by about 10 years later, after a second attempt by a group of mathematicians, skeptics, scientists, okay, primarily led by a computer programmer by the name of Brendan McKay, professor of computer science in Australia, him and a group of other people, they made a first attack. It was torn apart. But the second attack they had was published about 6 years later, around the year 2000, in the very same journal as a rebuttal. And they said like this, you're never going to believe what their attack was. Come on, figure out. I told you before. Who can remember? What's the key phrase? It's on the board. Cherry picking. They said, we have a way that you could have possibly cherry picked, even in this example that didn't fall through before. And Shimon, you mentioned it. The answer is rabbis' names. They said, maybe that is where the cherry picking happened. In other words, why did you look up the Rambam? Okay, fine, Rambam is by far the most famous name as how he's most known by. But why did you look up Moshe ben Maimon? Why did you look up Moshe? Why did you look up Moshe ben Maimon? The Ram, he's known in so many different ways. And also we found in one Venetian Shulchan Aruch, his name was misspelled with an ayin in it or whatever, okay? So look that up too, because it's printed. If you take all the different possibilities of all 34 rabbis, all the different combinations, they showed that, yes, you could get a statistically significant number even on a fake monkey text, or for that matter, Moby Dick and War and Peace. It is possible if, now granted, What they would be saying, though, and in the statistical journal, they didn't want to attack this famous professor. But granted, as I mentioned before, from the beginning this was understood to be a problem. That's why an esteemed professor is the one who gave the list, but they kind of implied that maybe he was part of a conspiracy with the researchers to help them that, whatever list you need, whatever you find, I'll say that's the main list. Okay? And they came up with the list. Now, granted, if somebody gave the list of the rabbis, that's kind of the funny part. If you went to a scholar and showed the list of the 34 rabbis that they used to get the results that we saw up over here, it would be some appellations that, even scholars have never heard of. What's this? The Jabalababu. I mean, I don't know what that is, because once a Jabalababu was mentioned. Okay? But nevertheless, you have it knocked out. You have a rebuttal in the same statistical journal. So the researchers were not so freaked out. Actually, they were kind of happy because they had a letter from the original editor from when it was published in 1984 saying that if there was an attack on their work, they would have the right to respond in the same journal. And their response was like this. I mean, they had a bunch of responses, but the main point was this. Hey, okay, you don't like the results over here. You're saying this is really just based because of the way we choose the rabbis' names, okay? But Brendan McKay et al., when they made their attack, as I mentioned before, of the cherry picking, that was only their second attack. Their first attack was saying, hey, how do we know that the information you use is correct to begin with? Maybe the encyclopedia had the wrong information. Maybe using wrong information. Encyclopedias are known. Sometimes they have the wrong, say, date of death. So they hired a photographer to go around the world and take a picture of the tombstones of all the 34 rabbis. And guess what they found? Yeah, take a guess. The encyclopedia had the wrong date of death. For how many rabbis? 2 rabbis. The whole experiment is no good. You have to rerun it. And when they reran the experiment, the results changed. Instead of being 1 out of 60,500, it's now the odds of a chance being mere 1,694,000. And as if some of you figured out what in the world happened. When the original experiment was run, only 32 out of 34 rabbis came out statistically significant. Yes, now all 34 out of 34 rabbis came out statistically significant, which avoids any philosophical issues. But much, much more importantly for this is the key. The whole basis of the attack is that you guys are choosing which appellation of the rabbi you want to use. And then once you find that, so that's our experiment. It's, so to speak, I throw the marker, right? It's like the phrase, first shooting the arrow and then drawing the target around it. But now you hear the second time it was run. Because remember, the first time, it didn't have the right information of dates. When they ran it a second time, you can't claim that they shot the arrow and then wrote the target about it. They were locked in with the names of the 34 rabbis. They couldn't change that. What they only changed were the dates. So you can't say, it's the chutzpah, that these very same guys are saying that we could have cherry-picked. You know we couldn't have cherry-picked because it was of you. We found out that actually the encyclopedia was wrong and ran it according to your information. And if it's not good enough, since then we've run other experiments, because now there's already the year 2000, 2001, and now it's on the entire Torah, not just in the book of Genesis. A lot of them avoiding the whole issue of appellations. Nobody argues, for instance, on how you spell the tractates of the Talmud. And what did the statistical journal respond? They said, very nice, but tough. We had enough of this. It was an embarrassment. We're done. We don't want to hear about codes again. So what did the researchers do? They pulled out, hey, we have the letter from the editor. They said, hey, yeah, go ahead, try to sue us. That editor doesn't work here anymore. The law is in America. Anything signed by a previous editor, once he no longer works there, is null and void. We're out by a technicality. So now you know that generally speaking what's been going on. However, I have to admit, it's true if we're going to be totally scientific on this in terms of evidence. it's not really fair for me to say, oh, it was peer-reviewed, because it was peer-reviewed. And even though now you know there's a lot more going on, at the end of the peer review of the statistical journal was revoked. I might say, hey, that's not fair, and they were playing games, and they wouldn't let them respond. But still, at the end of the day, there's no peer review. And that's why if you go look this up on Wikipedia, that's where the sad story about, oh no, those codes ends happy. Okay, it was peer-reviewed, but the peer review was knocked out. But what they won't tell you on Wikipedia, or at least maybe it's embedded somewhere on the page, but they don't want to talk about it too much, is that it was peer-reviewed again. Here it is, specifically, as we mentioned before, the issue, since it's cherry picking, it's really more about pattern recognition. And here it is reviewed again in August 2006. And as we know, one of the main reasons for peer review, why do you get it published? Because it's not really accepted in the scientific community until other scientists in the same field see the works, run the experiment themselves.
The verification doesn't count as proof. It has to be subject to a serious attempt to rebut it.
Exactly. And that's why this is particularly significant. Because over here you have Professor Robert Herlick. You can look him up on Wikipedia, do a Google search, whatever you want. Okay, he is considered an expert, particularly in pattern recognition. Had nothing to do with the original experiments. Because of this, he runs experiments himself. He has a website, which, interesting enough, anti-codes people keep on trying to take down. Okay, and completely and utterly separate from the original researchers, he finds the same results. And here it is, peer-reviewed. He was big enough to get it, even though really the scientific community didn't want to touch codes anymore, he kind of was able to ram it through. And there it is, peer-reviewed again, with other people as well who are also not part of the original work. And what does the scientific community who are against code say about this peer review? Absolutely nothing. Shh. Oh, we already disproved codes. We don't need to do it again. But it's been peer reviewed again by completely different people. No. In fact, the funniest is one of the biggest anti-codes people. Actually, I've met him. He's a nice guy. I have no problem with him per se. We just agree philosophically. His name is Barry Simon. He has an anti-code. I'd say one of the better anti-code sites if you want to look it up. Okay, he's a professor at Caltech University. Religious guy. What does he say about this peer review on his website? Well, Professor Herlick is such a big name in pattern recognition. The peer review board probably didn't do a good enough peer review. They probably just rubber stamped him. Is that a possibility? Yeah.
That's ridiculous.
It's a possible, but right, it's not. It's not a scientific answer, that's for sure. Okay?
I don't like the guy's background. It's not a scientific.
Yeah. Well, he's not even saying. I mean, he's the opposite. He's admitting, he's so big that they just rubber stamped him. It's the opposite. They didn't do a proper peer review. Okay? Maybe that's true, but come on. Is that a scientific answer? So where it stands today, am I saying base your belief in Torah on codes? No, don't do that. It's another piece of evidence. And maybe the people who are against codes, maybe they'll disprove it. I mean, so far, this has been since 2006. They haven't disproved this peer review yet. They feel they don't need to anymore. But I would say that the ball is in the court of the people who are against codes. The fact of the matter is, as it stands right now, there's peer review. It hasn't been disproven, and even the old peer review that was knocked out was really on a technicality. So therefore, I would say that it is another piece of the puzzle to put in as it stands right now. Statistically, we have peer-reviewed codes. They have not been disproven yet by the scientific community.
Has it been proven on future events that you can verify it?
We're going to get there right now. What time are you supposed to teach? 4 o'clock, 4:05, 4:10? 4:10? 4:05. Okay, so just 2 minutes, and then you're going to have a break, and anybody has any questions, because I want to make sure we don't get too far behind. Okay? I know we started a bit late, but what can I do? Let me show you some examples, and then you'll actually see them come up, okay? Now, this is actually not an example of this, but I'll show you very quickly, okay? They looked up the Holocaust, since obviously it's a pretty, unfortunately, central event in the Jewish people. It went too fast, okay? Notice over here you see Berlin and Germany and Nazi coming together, okay? Here's Berlin. We're now just moving up right over here. On the other side, right before the codes we saw down, now we see that they're also Nazi, Hitler, evil, and other things clearly relating to the subject appearing right above. Now we're also just moving to the side. Before, the codes that we saw were over here. Now on the other side of Berlin, we see Nazi appearing 3 times in a row. And Look at those numbers. Amalek and swastika, and I'm not going to get into Amalek's connection because you're going to have an hour class right after that, who is Amalek, okay? But look at those skips. What do those numbers tell you? These are the only time that these appear in codes, and they're not likely to actually appear anywhere in the Torah. They're literally on top of each other, okay? Right next to Berlin and Nazi. Just another one dealing with concentration camps. There you see Auschwitz, Eichmann. Another one, Auschwitz and Eichmann. And this is the real wild one. Look at that. Zyklon B. Eichmann. 3 times in a row, Eichmann with things associated clearly. Okay. Twin Towers. Now we're getting a little into your question, Shimon. Okay. Now, when the codes researchers I spoke to, I didn't fully know the story until quite recently. Professor Rips told me that soon as the Twin Towers happening, obviously it's like such a major, in our lifetime, it's probably the biggest event that's happened. Okay, unfortunately, tragic event, but it's defines our era. Okay, so of course they looked for it right away. What did they find? Okay, here they found the code, and by the way, this was one of the things that was peer reviewed. I showed you the second time. Okay, but what's particularly strange over, they noticed that the context of this is the sin of the golden calf, and in the text itself, it says roughly 3,000 people died in that day. Now, the question is, at that point when it first happened, we didn't know how many people died. So they said, maybe it's possible, since you have this right by the code, maybe that's saying that roughly there's going to be roughly 3,000 people dead. Okay. Now, immediately after, they were saying that no, it wasn't like 3,000. They said tens of thousands. They said, okay, so I guess we were just seeing things. The code still stands, but in terms of its predictability, it didn't. There doesn't seem to be any relationship. But what happened after months and months passed, and they started finding, what was really going on? Anybody know, as it stands today, over a decade later, how many people died in the Twin Towers? 2,900, at least the last time I checked Wikipedia a month ago. 2,998, give or take a few. What? Huh? That includes the Pentagon? Okay, fine. Wow, okay, you know better than me. Fine. So there you go, 2,998, give or take a few. So there it seems that there could be some predictive powers. Can you really use it? I don't know, but that's a...
You couldn't use it because you would have, because each thing is so detailed. You would need to imagine every possible event and every possible combination.
Very good.
And then check them all.
Yeah. Unless you had, that's the thing, you could really only do it after the fact. I'll show you another example.
Infinite amount of things, because infinite amount of things can happen in the future.
True.
Infinite amount of people dying or living.
And that's why you see, I'm going to show you another example where they kind of half figured it out, but they really didn't know what happened until afterwards. But first let me show you this, which is even more basic, which sometimes, like on this, you can't even look up until it already happens because, for instance, until the tsunami happened, nobody even called it a tsunami. I mean, I never heard of tsunami until the tsunami. Everybody called it a tidal wave. Okay? So only once the event even happened, so then it would even be possible to look up. You never even find it at all. But in terms of what you're talking about, Jonathan, this is a more recent one. I only got this from Professor Rips a couple of months ago. Okay, in 2007, actually I went too quick, I don't want to show you that yet. In 2007, they found this code. And basically what it says in Hebrew is like basically that some sort of nuclear weapon of mass destruction that was initiated got stopped. And when this happens is in the Hebrew year of Tafshin Samech Zayin, which is 2007. They're like, well, we haven't heard of anything, and this doesn't say where. It doesn't really give any information at all. And then the news story broke. The New York Times leaked that Israel, because Israel never says what they do, secretly, and thank God now as we know what was going on in Syria, secretly bombed Syria. Syria was creating nuclear reactors. Okay? And after it was done, then they had a location and what it was. Before it just said some sort of nuclear, but it didn't say what. Now we know it's nuclear reactors, and we even had the location, Deir Azur. So after the event went, this was saying, wow, this is weird, 2007, something nuclear stopped. They plug in the location and what it was, nuclear reactor, and it falls right over in the same spot. So as you can see, it seems that you can kind of find some information. After it was leaked, and then they knew the location, then they could find it. But before that, they
never disclose anything we've done.
Yeah,
well, no,
but the creep.
Get credit for a bunch of stuff we don't do either.
True, but the creepy part, once again, why this is interesting, is because before it was leaked and nobody knew what happened, they found in the Torah, like, wow, this is significant. It says over in here, some sort of nuclear device stopped, that was initiated, stopped, and it happens in the year 2007, but we haven't heard anything. We don't know where, who, what, when, where, why. Only after it happened, when they found the pieces, did they find it was linked in. Okay? And last but not least, some people want to know, okay, let's use the codes for the big one. Messiah. Who's Messiah? Who's Mashiach? So, for fun, they went and plugged it in. But still, it's a good philosophical point. They said, who is Mashiach? What's the name of Mashiach? So they ran it through the computer. Here it is, Shem Mashiach. That is the smallest skip of, what is the name of Mashiach. And it happens to run right through a verse in the Torah, which happens to say, why are you asking me my name? Thank you very much. You have a 5-minute break, and I'll stay for questions.